We'll now look at performing hypothesis tests for two independent samples and their means. We know the first step in a hypothesis test is to state your hypotheses. And when we have two samples, these hypotheses are going to look slightly different. My null hypothesis will be of the form mu1 equal to mu2. The first mean is equal to the second mean. And this is always going to be the case when we're dealing with two independent samples. It will always be mu1 equal to mu2. So what about the alternative hypothesis? For the alternative hypothesis, we still have three options. Mu1 is less than mu2, mu1 is greater than mu2, or mu1 is not equal to mu2. And these can be really tricky to figure out which one it is. Before, when we were looking at the problem, we were really looking for words like less than or greater than or smaller or larger, increase, decrease, things like that. But these can be really tricky and we really have to pay attention to which one of these is supposed to be the bigger one. The second thing is to find the p-value, and once again we're going to use our calculator to do this. For our calculator, we're going to use the command t-test2. We then need to enter in all of the information for our first sample mean, standard deviation, and sample size. We then go to our second sample mean, standard deviation, sample size, the direction of the tail, and then false, just like we had for confidence intervals. Finally, we need to state our conclusion, and just a reminder, if a p-value is smaller than alpha, we know that HA is true. So let's look at some examples of this. Here's my data for my example. These are two brands of medication, brand A and brand B, and the sample mean, standard deviation, sample size for how long it took these medications to start working. So brand A had an average time of 21.8 minutes with standard deviation 8.7. Brand B had an average time of 18.9 with a standard deviation of 7.5. And we want to use a 5% level of significance to test the claim that there is no difference between these two brands. So we start with our hypotheses, and like I said before, the null hypothesis always looks exactly the same for these type of problems. Since we want to test that there's no difference, we don't care if one is smaller or greater, so we just want a not equal to case for the alternative hypothesis. Since we're dealing with two means, we're going to use the t-test2 command. We then need our information from the first sample, so the first brand A information. We then have the information from brand B. We need the direction of our tail, in this case not equal to. And finally, when we're dealing with two means, we need to include the false at the end. Now that we have this, we can move over to our calculator. We click the three dots, down to statistics, to the t's, and we want t-test2. We can then enter our information. The first group, brand A, had a mean of 21.8, standard deviation of 8.7, and a sample size of 12. Brand B had a sample mean of 18.9, standard deviation 7.5, and sample size 12. We then go to the ABC and our symbols to get our quotation marks and not equal to, comma, and we type the false. We can see our p-value is 0.39. We then need to compare this with alpha, which is 0.05. And since the p-value is bigger, we say H0 is true, so there actually is no difference here. These two are going to be about the same. They take approximately the same time to kick in, to start working. So this example is similar to the last. I have two medications and I'm checking how long on average does it take for them to start working. However, this time my data is a little bit different. And this time, brand B actually claims to be faster, and we want to know if this claim is correct. So let's start with our null hypothesis, which always looks the same. And then the alternative hypothesis. Brand B is claiming to be faster, and faster means a shorter time, so we should expect brand B to be smaller. So the alternative hypothesis would be mu1 is greater than mu2. Since mu2, brand B does need to be smaller to justify it being faster. Since we have two means, we need to use the t-test2 command. We start with brand A's information. We then have brand B's information. We need the direction of the tail, which is greater than. And finally, when we're dealing with two means, we need the false at the end. So now let's move over to the calculator and find this. So I'll click the 3 dots and t-test 2. My first mean was 20.1. The standard deviation was 8.7. Sample size was 12. The second mean was 11.2. Standard deviation was 7.5. And the sample size was 8. We go over to the ABC and the symbols to get the quotation marks. And this was a greater than test. And we then need to type false. So the p-value is 0.013. We then compare this with alpha, which is 0.05. And we can see that the p-value is smaller. And when the p-value is smaller, we know that HA is true. So yes, brand B is faster. Their claims are correct.